Welcome to the first video in our study of geometry. Now, geometry as a set of ideas and a series of applications has been around for millennia upon millennia, even if we wouldn't recognize it as the modern study of geometry that we are doing here in this course. But some of these same ideas that are going to come up in this course were utilized by ancient civilizations to create impressive feats of architecture that still exist to this day. Famous one being the pyramids at Giza, but a less known one being the megalithic temples that exist on the island of Malta, some of the oldest known buildings still standing that by some accounts are as much as 9 to 10,000 years old. But you ask most people about geometry and where geometry came from, they're not going to tell you the Egyptians or the Maltans or any of the other civilizations that also used those ideas. Most people, at least in the Western Hemisphere, would tell you that geometry started with the ancient Greeks. And it's not because the ancient Greeks had these ideas first. They didn't. They were used for thousands of years before the ancient Greeks. The reason geometry is attributed to the ancient Greeks is because of the contributions of this man. No, that's not Pythagoras. Although if you thought it was Pythagoras or immediately had the name Pythagoras pop up, nobody could blame you because for a lot of people, that is the most famous Greek mathematician that there is. But arguably, one of the most influential Greek mathematicians that ever existed is this guy, Euclid. And Euclid was influential because he is the first person that we know of, and that's a key part of this. He is the first person that we know of and that we have records of that took the ideas of geometry and broke them down into small component building blocks, a small number of component building blocks, as well as a small number of ideas that we accept without proof to just be true, called axioms, and recognized that by applying deductive and inductive logic and some rigorous proof processes to it, you could build out the entire rest of geometry. And that sort of thought process that you take with basic ideas and then you do some reasoning around it and you prove that other things were true and you build out of it has impacted the study of mathematics across all of its different fields. And so the field of geometry that we're going to be studying in this class is called Euclidean geometry, named after Euclid. Now, a lot has changed in the 23 or so centuries since his death. There are other fields of geometry that you might study later on if you're interested, called non-Euclidean geometries that have some really fascinating properties. But the world that we experience, the 3D world that we live in, by and large, as we interact with it, is a Euclidean space and follows the rules set out by Euclid. So, let's get into geometry, the building blocks, and some of the ways that those building blocks interact. First, we should have a good definition of geometry if it's something that we're studying. So geometry, by definition, is the study of objects and their properties in a space. It's not a particularly glamorous definition. It's a little bit vague and it leaves a lot up to interpretation, but geometry has a scope that is that big. And everything that we talk about with geometry is the study of objects, their properties, their interactions in whatever space that they exist in. So that brings us down to those fundamental objects of geometry. The first is the smallest object, which we call a point. It has no size. It is what we call zero-dimensional because it does not extend in any direction, and it represents a single precise location on a plane, on a line, in a space. We can't obviously see something that has no size, so we represent a point with a point drawn with a little bit of thickness so we can see it on a line, a plane, in a space. And we mark points using capital letters. Now, if we have a second point, perhaps one called B, and connect them infinitely in both directions, we get something called a line. It technically has no thickness, even though what we see there, for the fact that we need things to be slightly thick for us to see them, is one-dimensional. It has length in both directions, but no actual thickness. Points marked by capital letters, lines marked by lowercase letters, often cursive lowercase letters, but they don't have to be, or by naming two or more points that are on the line. Now, if we extend that out to a flat surface, then we call it a plane. And that's something that you're familiar with because you looked at a coordinate plane or a Cartesian plane as a part of algebra previously. And that flat surface called a plane, to truly be a plane, extends infinitely in every direction with no end. Obviously, what we see, like the flat surface of a table or the flat screen of a computer, does not extend infinitely in all directions, but the idea of the flat surface is what we mean when we talk about a plane. Once we extend that up into 3D space, that's it. Those are the basic building blocks of geometry: a point, a line, a plane, and space. Everything else that we study is going to be built from them. which is a powerful thing about geometry, is that it comes from a relatively small number of objects. They're going to be built from the objects and from the interactions of the objects and how their properties mix. So what I'm going to ask you to do now is something that is going to be familiar with you by the time we get to the end of the course. I'm going to ask you to pause the video and write down all the definitions that you see on the screen here. A point, a line, a plane, the line through points A and B called L, all of the things that are on the screen. Come back when you're ready to move on to see some properties about interactions of those objects, and then continue the study of geometry. So another way that we can describe points is according to their relative orientation to each other. You might notice that on the left-hand side of the screen, A, B, and C seem to be forming a line if we were to continue down from the top left to the bottom right corner of the screen, whereas E, D, and F, maybe two of them are on a line, but not all three because there's a little bit of an arc or an indent there. Well, if 3 points lie on the same line, we call them collinear. If they don't, like E, D, and F on the right side of the screen, we either call them non-collinear or we just don't call them anything at all. Now, the interesting piece of collinear isn't what happens when 2 points lie on the same line, because between any 2 points there exists a line. What happens, or what is interesting when it happens, is when 3 or more points lie on the same line. So that's really when we call them collinear. Again, pause the video, copy the information on this screen down, and come back when you're ready to move on. Well, we talked about intersecting lines and points, or we have seen intersecting lines over on the right-hand side here, and we have seen points lying on the same line. Well, you might ask, can we naturally extend that to points lying on the same plane? And of course we can. And if we call points lying on the same line collinear, we call points lying on the same plane coplanar. So let's take a look at some examples here using the sort of beige, pinkish, and blue planes over on the right. Those represent planes. The beige one or the pink one is relatively flat, and the blue one is relatively vertical. So a series of points that lie on the horizontal plane might be the ones that we see here. All those points are coplanar because they fit on the same plane. But a point that exists a little bit higher or a little bit lower on the blue plane, they are coplanar with each other, but they are not coplanar with the points that exist on the flat plane. A series of points called coplanar must be all on the same plane. So go ahead, pause the video, write down this definition here as well as this diagram. Come back, we have one more thing to look at, and then a quick review of those building blocks. So as we've seen both in our diagrams with lines or points that are collinear and non-collinear, and points that are coplanar and non-coplanar, objects in geometry might intersect with each other. And that's what we call it when two objects cross. So the image on the left, which is 2 planes that intersect, you can see the dashed line represents the intersection there. And the diagram on the right, line K and line M seem to come together at point E. And that is a property that we call intersecting. We're going to talk a lot about things that intersect, talk a lot about lines and planes that intersect, but this is the last of the truly building block ideas that we have. Everything else that we study is going to come from these objects. So, as a quick review, a point, the smallest object in geometry, represents a single specific area in space, has no size, it is 0-dimensional. Connect 2 points, extend it infinitely in both directions, and get a line that is 1-dimensional. Get a flat surface that extends with no end in any direction without any thickness of itself is called a plane that is 3-dimensional, and a plane that is 2-dimensional, rather, and the world as we experience it is a 3-dimensional location that we call a space. Those are the building blocks, and that's what we're going to use to study all of the rest of geometry.